Okay, welcome back. In machine learning, models are built from the ground up using training data. So when a model isn't performing well, it's tempting to think maybe we just need more data or better data. It's a natural instinct to want to increase the training data. But does adding more always make the model better? It turns out not necessarily. Let's dive in and find out why. Imagine we are back with our cancer diagnosis model from the last video. It's designed to predict whether a tumor is malignant or benign based on medical data. But in practice, you find your model isn't doing so well. So your first thought might be, let's get more training data. Maybe we could visit more hospitals, collect new patient records, and feed them into the model. But hold on, before you spend time and money, let's see what really happens. Because here's the catch. More data doesn't always fix the problem. In our last video, we learned that a struggling model might suffer from one of two issues: high bias, well, it's too simple and underfits the data, or high variance, well, it's too complex and overfits. Let's break this down and see how extra training data plays a role. First, let's see high bias. We drew a straight line as the decision boundary to separate green dots from red dots. This is a supervised logistic regression model, a simple classifier. Mathematically, the expression of this decision boundary is something like fx equals to wx plus b. Well, w and b define the line. Now, we already know that this model is underfitting. It misses key patterns in the data, like these regions. So what happens if we add more data? Well, it looks like this. You must notice that more data just gives you more of the same story. Training the model on this data may tweak W and B a little bit, shifting the line slightly. However, these regions stay misclassified. It is still too rigid to capture the true complexity. The performance barely budges, so for high bias, more data isn't the answer. Now, let's flip to high variance. We drew a super complex model, one with a wiggly decision boundary full of curves like a roller coaster. To get those curves, we might use a function with lots of higher degree polynomial terms, like this one. With just a little training data, this model can twist and turn to fit every single point perfectly, even the random noise. We know that's overfitting. But what happens when we dump in more training data, like this? Suddenly, it's harder for the model to chase every quirk, the noise. It has to settle down, smooth out, and focus on the big picture, the true pattern in the data. Check this out on the chart. With more data, the boundary gets clearer and less erratic. That's a win. But here is the twist. This only works if the new data is diverse and high quality. If you just duplicate what you already have, don't expect too much change. Okay, takeaways. So, does increasing training data improve performance? Well, the answer is it depends. For a high bias model that is underfitting, more data won't save the day, or at least the gains will be tidy. You're better off making the model more flexible instead. Remember training the lazy dog to fetch your sleeper? If we show it more sleepers, brown, green, fuzzy, it still just wanders around. More training data doesn't wake up this sleepy pup. It's like a simple model that stays underfit no matter how much data you throw at it. For a high variance model that's overfitting, yes, More data can help tame it, but only if that data brings fresh, meaningful variety to the table. Remember our red sleeper obsessed dog, the overachiever? It nailed the red sleepers but flunked the blue ones. What if we gave it tons of sleepers? Blue, green, polka dotted? With enough variety, it stops fixing on red and non-sleeper means full well. More diverse data tames this wild model, but only if we mix it up. Experts have a toolbox packed with tricks like feature selection, regularization, or cranking up model complexity, but the real magic starts when you figure out if your model is suffering from high bias or high variance. In machine learning, tuning a model is all about this practical dance between data and complexity. And this logic doesn't just apply to logistic regression, it holds for neural networks, deep learning, and beyond. In my next video, I will walk you through the step by step process experts use to train and tweak models like this. See you there.